So the goal of this video is not to teach you anything directly about Python, but how to get started using it quickly using a programming editor that you'll be using throughout the semester. So this video is just a quick start for learning how to use this editor, and it's called Mu or Mu. Although you may have used other editors for programming, whether it be Python or other languages, we're going to guide you towards using Mu for a couple of reasons. First, it's relatively small and fairly simple to use. There's not too many options to be confused by, given the number of different things that it actually can do. Second, it also includes a basic debugger that can be used for debugging desktop programs. Having access to a debugger can be especially useful when you're just learning Python or any other language for that matter. And third, it can be used to program regular desktop Python as well as for programming and interacting with your hardware boards, which you'll start learning about and using in the next couple weeks. First, you need to download the installer for the program. Go to the website codewith.mu and click on the download button. And there are two versions of Mu available for download. The first version mentioned here, subtly, is the alpha version, which is the next version of Mu that isn't quite complete yet. To be honest, the alpha version's been the test version for a long time now. It hasn't changed much. I have no idea when he's planning on upgrading or completing this version, but this is actually the version that I'm recommending that you download. The stable 1.0 version is under these nice pretty icons and stuff down here. Don't be distracted by those. I'm recommending that you get the alpha version. It's been very stable. I've been using it for close to a year and I actually prefer it. If for whatever reason you inadvertently or intentionally want to run the older, more stable version, you're welcome to do that. However, some of the icons and some of the labels on buttons and things are different from the older version to the newer version. So just go ahead and get the newer version, please. So once you download the right version for your laptop, it just goes and gets it. Now, using the magic of television, I already have a copy here downloaded. So let's make sure I don't have one running. I don't. So if I were to go ahead and install this, pretty much of a standard Windows install. Next, agree. Now this is really about the only choice you have to make. This is fairly common for a lot of Windows applications. You have the option of installing it for everyone using the computer or just for the user that's logged in. Since almost everybody only ever uses one user on their PC, and because it actually makes subsequent updating easier, I recommend just doing an install for me. So you would click next to take that as the default. Gives you the destination folder that it wants to default to. Take the default. And if I was to hit install, it would go ahead and install it. It would take 10 or 15 seconds to install. I've already got it installed, so I'm going to cancel out. And we're going to pretend that that never happened. And I'm not sure, do I want to, yes, I'm sure I want to quit. So now that I have installed Mu, I happen to have created an icon for it and stuck it here. If you're a regular old Windows user, you're going to find it down here under alphabetically Mu right there. So I will warn you that there are some installation or running issues that I've seen on both Windows and Mac OS. So from past experience, I've seen that a small number of students have said that after they've installed Mu, they've had no desktop or start menu icon like the one I just showed you to launch from. So what we've determined is that if you just go ahead and you run the installation program a second time, that always seems to clear up the icon, the launch icon issue. Don't bother uninstalling the first issue, just slam the first installation, just slam down the second installation on top of the first, and I've never seen it not work the second time. So if you don't see how to launch Mu, then go ahead and reinstall it. Install it again. Now on Mac OS, there's a different issue. Depending on how you've got your machine set up, Mac OS tends to want to generally complain that whenever you get an application that doesn't come from the App Store, that it usually whines about not wanting to run it because there could be evil lurking inside. So there's typically two ways to get around this problem. You may have already done this and not realized it, but the first way is to change a global setting in your control panel that allows you to run foreign apps without Mac OS complaining about where you got that dirty program that you're installing. The second way is there's actually some magic 1 or 2 key combination that you can press and hold whenever you launch the installer, and it overrides any sort of extra checks about whether it came from the App Store, and it just goes ahead and installs it. So there is a link to one such article that I'll put in the notes, but it's basically this knowledge base article right here from support.apple.com, and I'll link to this in the notes for the video. So assuming you can install Moo and run it successfully like I have here, this is what you get. So on your first installation, you should see pretty much exactly the same window. It's just an empty code window with a comment in it. But I will warn you that later on in the course, you may find yourself going back and forth between using Moo to program your hardware microcontroller board and perhaps running Python 3 on your laptop. So know that Moo can work happily and help you do both. The problem is that you need to tell it which you're going to be doing, because there's some different options, different icons that you'll see up here in the icon bar, depending on whether you're intending to run Python on your hardware board or if you're intending to run it on your PC. So if you're intending to run Python 3 on your PC, what you should see down here in the bottom right-hand corner is it should say Python. Or Python 3 if you're running the older version, I believe. If your hardware board was either last used and you restarted Moo, or it's actually plugged in at the time you launched Moo, you may get a dialog box that says, hey, the last time you ran Python, you were using it for desktop Python, and I see that you've got hardware out there. Which version of Python do you want me to use, the hardware version or the PC version? And so you may be given a dialog box that comes up, which is actually, it'll have some explanatory text, but I think if you click OK at that point, it'll send you into the same dialog or the same choice box that enables you to switch modes back and forth at will anyways. So to switch modes, let's say I'd come up in the wrong mode. Let's say I'd come up in CircuitPython mode, and you would get a clue that it's in the wrong mode by the virtue of the fact that it says CircuitPython down here in the bottom right-hand corner. So I would see that, and I would want to switch my mode. So I just click on the mode button and choose Python 3 mode. So it's called Python 3 in that selection box, but the label down here actually says Python. A little bit confusing, but that's just the way it is. So that's the mode you want to be in, at least for the next couple weeks. And once you start using hardware, you'll want to be in the other mode. So Moo, if it recognizes that a board is plugged in to your USB, which is how your hardware board is going to connect to your computer for programming, it will offer to switch automatically right over to CircuitPython mode, which if you've got your hardware connected, that's probably what you're planning on doing anyways. So in that case, you just take the default and it would switch you over to CircuitPython mode. If you need to override it and for whatever reason manually, then you can just come back here, click the mode button and go back into CircuitPython. But that's not what we're doing right now, so that's not what we're going to do. So I've showed you how to use the mode button. So kind of a word of warning here, the options and the features for editing with Moo are very limited, which is an advantage and sometimes a disadvantage. So I'm just warning you, don't expect too many fancy bells and whistles with this particular editor. In fact, if you look up at the top, there's not even any sort of options menu. So that should be a clue that there's no options for you to set. There's no customization that you can do with Moo, which once again can be an asset or a liability depending on how you look at it. So one thing that I will also warn you about that you may not appreciate with Python if you haven't used it already is that Python is very sensitive about how you indent your code. The indentation of your code is important for how your code actually gets executed. This isn't really the case in most other languages. In fact, I think Python's about the only language in which the indentation uh, is conscious. It needs to be done in a specific way, otherwise your code isn't run correctly, or at least not as you intended. So the practical reason why this can be an issue is if you use multiple programs to edit a piece of code, or you get it from someone else that's not as diligent as you are, um, the presence of tabs and spaces, both of which are invisible characters in a text file, will put you in a sort of version of mini hell, because you can't easily tell the difference between the two. So you won't typically find this out until you start running the program, which may look visibly just fine on the screen, but Python will complain. It says, hey, listen, the indentation for this is wrong, or in some other way, your Python program is not syntactically correct. So if a program looks like it's indented fine to you, let this be a warning that it could very well be this tabs versus spaces issue. So there are utilities out there in the real world that allow you to convert files that have tabs in them and pad them out with spaces instead. But for the most part, unless you've got a really big piece of code or multiple files that need to be converted, it's usually not worth it. So you can either manually go around in your code and move the cursor to convince yourself that there's no tabs in your code, or you can just run it and fix the problems as they occur. And the way to do that is typically just to go to the line that's being complained about, move your cursor around, and if it ever jumps to the right or to the left when you're moving right or left, then you'll know there's a tab there and you need to murder that thing and replace it with spaces. So I'm going to actually show you how this works in practice. So I happen to have a file already around that I created in Notepad, or maybe I created initially in Moo and I decided I wanted to edit it in Notepad, and so maybe I went off for a couple minutes or hours and used Notepad, and then I came back to Moo and loaded it back in. So this file happens to be called bad hombre because this file's a bad hombre. So this looks like a perfectly valid, syntactically correct Python program. The indentation is such that the two print statements are done inside the for loop. The problem is that when you go to run this, it says, hey, there's a problem in line 3. There's some sort of inconsistent use of tabs and spaces. Now that's a pretty clear warning. That says tabs and spaces is your problem. There may be other contexts in which it doesn't know that tabs and spaces is necessarily the problem that it's run into. So it may give you some other sort of syntax error. In this case, it was able to determine that, hey, listen, you were using spaces and then you switched to tabs. Now, the way to see this, there's no way to visually tell that there's something strange going on in this area of the screen. So if I was to, like, say, go move my cursor there and move it to the right to go to the next line and move my cursor to the right, every time I move the cursor, it moves what's pretty clearly one space worth of right to left motion. If I continue to do this and go to the next line and then hit my right arrow to, it jumps. Look at that. There's a tab here. This is a tab masquerading as 4 spaces. So this has told me that's at line 3. I've used my cursor to find out that sure enough it's at line 3. So the way to deal with this is just, you can either hit delete from here and delete the character that you're on, or go to here and go backspace, and then just manually put in 4 spaces. Now if I was to stop and rerun this program again, it would run the program and it would show me the output down here. So when it tells me that there's tabs, just start marching around with your up, down, right, left arrow cursor and find those tabs and murder them. Unfortunately, because Moo is such a simple editor, it does not have a feature for doing a find a tab. So most other editors, Notepad, Notepad++, probably even Word, lots of other simple editors will allow you to specify a tab versus a space to look for. In fact, it may even let you find all the tabs and globally replace them with 4 spaces. Moo doesn't have a fancy find or find and replace feature like that. So theoretically, you could use another editor to find them all and change them all to spaces. Or you can just, like I said, find them the hard way by stumbling over them line by line and then just changing them manually to spaces. So that's a practical file in which you couldn't tell from looking at it that there was a problem, but there in fact was a problem with tabs versus spaces. The nice thing about Moo is that even if you hit tab to do an indentation, it inserts spaces for you. So it never puts you in a situation where it's going to insert a tab for later torture down the road. So my recommendation is generally just to use Moo to create your source files, to edit them, and just forever. So go into Moo, create it with Moo, stick with Moo, live in Moo. Like I said, there's no guarantees that if you get a file from somewhere else or if you start cutting and pasting from somewhere else, that you're not going to inadvertently insert tabs. But as long as you're editing your own files and use the tab to do indentation, Moo will do the right thing for you. So even though Moo doesn't have very many options, that default option, that default behavior is really the one that you want. So I did it pretty quickly. So that's kind of the standard first program is a program that basically just prints out hello world. This is the syntax for how to print something in Python. So you just type in your code, and unlike a lot of other languages like Java or C or C++, there's no compilation step. You don't have to run a program to convert your program source into an executable program. Python, like MATLAB, if you happen to have used MATLAB as a prior language, you just type in your code and you say run, and it just goes ahead and it runs it. So under the hood, it does some optimization so that it doesn't run painfully slow. It actually kind of does some actions like compiling behind the scenes, but you don't need to know that. And for the most part, you just type in your program and you just execute it. So this makes finding a bug, modifying your code, and running again extremely quick. Whereas if you had to recompile your Java program or your C program, it might take seconds or some cases even minutes to do that. With Python, one of the joys of Python is that the debug, write, run again cycle is so quick. So I mentioned one of the 3 reasons why we're having you use Moo, even for desktop Python, is that it comes with a debugger. Now this program here is so simple that there's not really much to debug, but I have a little program here, which is, let me see if I can get it all on one screen. So this is the whole thing right here, you're looking at it. So this is, I didn't realize until recently, this is kind of, I wouldn't say it's the second program after Hello World, but it is a fairly common program, I guess, in computer science teaching. It is an implementation of a game called FizzBuzz. And FizzBuzz came about, I guess, as a game to help children learn how to do division. So children sit around in a circle and they start counting from 1 up to whenever everyone is eliminated except for the winner. So you go around in a circle and you basically count from 1 to n, and the game is played by any time a person is supposed to say what is a number that happens to be a multiple of 3, you're supposed to say the word fizz instead of the number that is a multiple of 3. Similarly, for multiples of 5, you say buzz instead of 5 or 10 or 15. So for instance, if you were to go around a circle of smart children, they would say 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz buzz. I forgot to mention the third case is any multiples of 15, you're supposed to say fizz buzz. So fizz for multiples of 3, buzz for multiples of 5, and if it's a multiple of 3 and 5, you say fizz buzz. So that was the number range from 1 to 15. So to write a program basically that does this in Python, this is a more complicated Python version than it needs to be, but it's complicated so as to show you why you might want to learn to use a debugger and learn how to use it to find bugs in your program. So this program probably could be written in about 5 or 6 lines, but I have made functions called fizz and buzz. You'll see why. And there's also a for loop here where it basically runs through the game from 1 to 31. So let's go ahead and run this program and so actually, this program doesn't have the bug in it that I wanted you to track down. So I'm going to revert this back to the buggy version. So now let's run this buggy version. So one of the annoyances of Moo is that, so the previous program we ran was Hello World, and you'd think that when a program runs to completion that you would just be able to, say, rerun it again. However, unfortunately with Moo, you actually have to hit stop. And when you are given the run icon, it runs whatever code is in whichever tab you happen to be looking at. So if I was to hit run over here, I don't even know what it would do. Okay, it says, oh, it forces you to always save a file. So it only allows you to run a program that's been saved most recently. So let's go ahead and save this. Let's save this as poop. And let's run it. Okay, so it ran, and it basically, since this program does nothing, it did nothing. Even though it's completed, you still have to hit stop and run to run it again. So the null program isn't very interesting. So let's go back over here and run our FizzBuzz program. So I have to hit stop. And the reason why you know you have to hit stop is because the run button you're looking for isn't there. So let's go ahead and run this. And let's scroll back up to the beginning and let's see if the program does what we expect it to do. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so the program's working fine except when we got to 15. Now the problem is it's supposed to say FizzBuzz for all multiples of 15. So at 15 and 30, let's check out 30. Let's just confirm that this is the one and only bug. Yeah, sure enough. In place of 30 should be FizzBuzz. It's not. It just says fizz. So why is this? Well, we could look at the code, or we could have more fun and show you how to use the debugger. So rather than hit run, you can hit debug. And what debug does is it starts to run the code and it highlights which line it's currently executing. So it may not be obvious, but even function definition statements are executable in the eyes of Python. So it would need to get, the definitions for this would need to get run before it gets to the real meat of the code, which is this for loop, which runs through all the numbers in question. So let's just let this thing rip. So when you hit debug, it stops before the first line that it's going to execute in the program. It gives you a chance just to kind of get your bearings and figure out what you expect the first couple of lines to execute are going to look like. So let's just let this continue to run. So continue means run the program to completion or until it hangs in an infinite loop or crashes or whatever. So in this case, the program exited, but we know from looking at its output that there's a problem. So continue lets it run until it has cause to stop. And we'll see why it might have cause to stop in a couple minutes. So let's stop it manually and let's go ahead and go debug. Now, there's a couple of ways to get a debugger to execute your program. So sometimes there's cases where you want to run a piece of code line by line because you don't know where the problem is and you just want to take it step by step until the thing, does something that you recognize as a problem, and then you know where the problem is. In some cases, you want to skip over any functions that it calls. And that is the difference between step over and step in. So step in, if there's nothing to step into, it just steps over the current line. Step over is used when you want to step over a function call and not go into the function call. So let's do this the slow way. Let's execute this line, then execute this line. Now we're going to actually start running our real code. So the first thing it's going to do is it's going to set up the for loop. And let's look over here on the right side. So this is the variables pane of the Windows setup. I guess in Mu he calls it the Debug Inspector. So over here we see what all has been defined, what variables have been defined in our current variable scope. And so buzz is actually a variable, it just happens to be a function in Python. Fizz is also a variable, which is a function, and here's our I variable. So the first time through the for loop, it takes on the value I. Now, if we were to hit step in at this point, it steps into the function that was at the next line to be executed. So it's going into the fizz function. And if we go over here and we look at the value of n, which is the parameter of the function, it's also telling you that it is the same as the copy of I that was passed in, which is 1. So if I was to step in, it would execute that statement. It apparently was false, and so it's going to come down here and it's going to return false. Does that make sense? Well, fizz given a 1. Is this a fizz? Is its fizziness true or is it false? Well, it's false. It wouldn't be a fizzable number unless it were 3, 6, 9, 12, etc., etc. So the next statement to execute is return false. So if you hit step in again, it falls back out of the function and goes back to the next statement that it's going to execute. So let's do the same thing again. So step in, think of step in as the smallest step that you can take. So it steps into buzz, it executes the comparison, and it also returns false since 1 is not a multiple of 5. So it returns false. Yeah. Now so we know it's 1 is neither going to be fizz or buzz, so it's certainly not going to be both. So this is a good case where I don't want to step into fizz and buzz again because I know what the outcomes are going to be. So what I would want to do in this case is do a step over. So step over says if there's any functions to be called in the next to be executed statements, that it should not enter them. It should run them, but it should basically step over them. And there it did. It stepped over it, and now it's going to execute the next statement, which is, in this case, since it fell through the if, else, else, it executes print I. So let's just step over that. So if print was our function and we hit step in, it would actually step into it. But since we don't own the source code for print, even if we say step in, it doesn't know how to do it because there's no source code in a known location for it to show us how to step in. So step in this case doesn't step into the function because we've got no control over it. It actually does the equivalent of a step over. So here we are, we're going to get ready so we haven't incremented I yet. If we look over here on the right pane, it still says it's I. If we were to do say it's just a step over, you will see I incremented to 2 over here. So we already know what's going to happen with fizz, but let's just do it the slow way again, just to get a real sense for how step in works. There it is. It stepped into fizz. We are not a fizzy number, so it returns false. Pops back out. We know it's not a buzzable number, so let's just save ourselves the extra couple clicks and do a step over. And we know it's not a fizz and a buzz, so let's step over it again. and it's going to print. You see a print 2 down here. Go to the top of the loop, step, 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 step. Okay, so it's doing 3 correctly. We saw the output from the program before. We know we're good until we get to 15. So rather than just hit step over, step over, step over until I eventually becomes, 14 is where you want to slow down. There's a couple of ways of getting around this. To save yourself a lot of clicking, what you can do is you can do what's called setting a breakpoint. Now, a breakpoint is an intentional stop in the program. So if I set a breakpoint here by clicking on the next to the line number, what I can do is I can hit continue at this point. Now, I told you continue runs to completion or until it finds a cause to stop. So there's typically 2 causes to stop. 1, you've run off the end of the program and there's nothing else to run. 2, your program crashes, it hits a bug, and it vomits, and it stops there. Or the third condition is if you've hit a breakpoint. So we've set a breakpoint. So if I hit continue here, it will execute until it gets to one or any of the breakpoints that I've set. So at this point, it stopped and I is 5, if you look over here on the right side. So basically what I'm trying to do here is I want to get to 15. So by having a breakpoint here, I can hit continue. And notice what it's done is it's basically continued up through the loop and it's hit it again and it's stopped again. So I is 6. So it's a fast way of executing a bunch of code up to a known point where you want it to stop. So I'm going to continue 7, continue 8, continue 9, continue 10, continue 11, continue 12, continue 13, continue 14. Now we know 14 does what we want it to do, so it's safe for me to continue one more time to get to the point where I is 15. Now 15 is the point where we know that the code should say fizzbuzz. So if we were to step, well, we don't actually need to step here. We can look at this code and we can know what's going on. But if you didn't know what the program was going to do at this point, you could just step slowly by doing a step in and realize that, oh, 15 is my n over here being passed in. Is it, step again, is it a fizzable number? Yes. So it's going to return true like we would kind of expect. The problem is that once we, okay, so one thing I haven't shown you here is step out. So if you happen to be in a function and you know what the outcome of that particular function is going to be, rather than continue to step through the function and just return, you can hit step out. So step out means continue to run the function that I'm in until it naturally returns, but then stop at the point where the function was called at the next executable line. So our I is 15 and it's going to print out fizz. Well, clearly that's not the right thing to have happen here. So we found our bug. So the problem is that these checks here for fizz and buzz need to happen before you check for either just fizz or just buzz. So we've found our bug by stepping through the program slowly, watching the path that it took that we recognized was not the right one, and we found our bug. So let's go ahead and we can hit stop now. We could hit stop later, but what we really want the code to do is we want to hoist this piece of code up here, and we want to make this an elif. We want to make this be the initial if. And let's just go ahead and run it and see if this fixed our code. So we know that 30 was a problem and 30 is now fine. Let's go back and make sure 15 behaved properly. And 15 did. So we're good. So what I showed you here were a number of things. I showed you, in fact, you have to actually be in debug run mode and debug mode for it to actually show you these options up here. So we learned how to launch a program under control of the debugger, right, in which it stops at the very first line and allows you to either continue or start stepping individually, line by line, or function by function, or whatever. So we've learned how to launch run, we've learned how to launch with debug, and we've learned how to free run continue. We've learned how to step over a function that we don't care about the contents of. We've learned how to step in, which means step line by line. And we've also learned how to step out of a function that we don't care what the rest of the execution of the function is. Annoying alarm. Okay, so that is how to use the debugger, and hopefully you will find this useful, perhaps for debugging your programs. Historically, when beginners get started, they just print out the values of their variables, and then they have to go and they have to remove all these debug statements. The nice thing about a debugger is, so not only does it show you as you're running the program line by line what the values of the variables are, you don't have to go ahead and put in print statements everywhere. So you don't have to have any, phase where you're going and cleaning up your code afterwards to remove all those annoying print statements that you put in there for debugging purposes. So this is I think this is the end of what I was hoping to demonstrate for how to use Moo. So Moo is nice in that it does the right thing with tabs and spaces. It's got a built-in debugger, and it will be used to also edit and run programs on your hardware boards. Now I'll give you a little sad premonition of the future. You unfortunately cannot run the debugger on programs that are running on your hardware. The ability for Moo and the hardware board to cooperate and act as a debug session doesn't actually work. So hopefully you'll fall in love with using a debugger when programming Python 3, but unfortunately you're not going to have that ability once you start running programs on target hardware. So that is it for the intro to Moo. I hope you enjoy it. My recommendation is that you go ahead and you stick with using this all semester, because it is the one and only tool you really need to get by. So I hope you enjoyed the video.